Hi students, good morning everyone. Hope everyone is doing well. In last video, we discussed what is an optical fiber and its advantages, and also we discussed construction and principle of optical fiber. So finally, this I will explain in one sentence. Optical fiber is a long, thin, transparent dielectric material. It is made up of glass or plastic which carries electromagnetic waves of optical frequencies from one end of the fiber to another end of the fiber by means of total internal reflection. Okay, is it clear? So finally what we conclude here, optical fiber works as waveguides in optical communication system. Okay. Now, coming to working of an optical fiber, it is working of optical fiber. So, how fiber works? How light propagates from one end of the fiber to another end of the fiber. Already we know the principle of optical fiber. So, what is the principle of optical fiber? Total internal reflection. Means once light rays enter into the core, they propagate by total internal reflection at the core cladding interface. So to explain this here, it is the fiber, it is the optical fiber. It consists of one inner cylinder, it is the inner cylinder. This inner cylinder we call as core and it is surrounded by another cylindrical shell, so that we call as cladding. Okay, here this core refractive index of core is slightly greater than cladding refractive index. So that's why here core acts as denser medium, cladding acts as rarer medium. Okay, here it is air medium. Refractive index of air is N. So air medium and it is core medium and it is cladding medium. Okay, now how light propagates in this fiber? Okay, now it is the light ray. AO is the light ray. It is incident at one particular point, that is the point O, with an angle of incidence theta naught. It makes theta naught angle with fiber axis. After this light ray, it is refracted into the core material with an angle of refraction theta 1. Okay, it is the refracted ray. Here it is OB is the refracted ray. Here it is core, it is cladding, it is the core cladding interface. It is the interface. Here also it is the interface. Okay. Now this refracted ray OB, it is incident at core cladding interface at point B with an angle of incidence 90 minus theta 1. Now we know to produce total internal reflections, two conditions must be satisfied. First main condition, light should travel from denser medium to rarer medium. Second condition, angle of incidence at core cladding interface, it must be greater than critical angle. Okay, so first condition, okay, what is that first condition? Light should travel from denser to rarer medium. Here core act as denser medium, cladding act as rarer medium. That is okay. Next one, angle of incidence at core cladding interface. It is the interface. Here it is the incident angle. If it is less than critical angle, what is critical angle? It is the angle of incidence at which angle of refraction is 90 degrees. Okay. Now, the angle of incidence at core cladding interface, if it is less than critical angle, what happens? Light rays refracted into the cladding. No reflection here. Okay. Now, here angle of incidence at core cladding interface, if it is equal to critical angle. If it is equal to critical angle, then light rays travels along core cladding interface like this. It is light propagates along BC direction. Okay. Now, to produce total internal reflection, one of the main condition, the angle of incidence at core cladding interface, it must be greater than critical angle. If it is greater than critical angle, light rays totally reflected back into the core material. Again here also, if two conditions satisfied, same process. Light rays total internal reflection takes place. Like this, light propagates from one end of the fiber to another end of the fiber by multiple total internal reflections. Now, How total internal reflection is possible here? Okay, so it is mainly dependent on angle of incidence at end face of the core. If angle of incidence at end face of the core, if it is less than or equal to theta naught, then angle of refraction, it becomes less than or equal to theta 1. Then angle of incidence at core cladding interface, it becomes greater than critical angle. If it is greater than critical angle, light rays totally reflected back into the same medium, means total internal reflection takes place here. Otherwise, what happens here? If suppose here incident angle at point O, incident angle, if it is greater than theta naught, if light ray is incident like this, what happens? Automatically angle of refraction, it becomes greater than theta 1. If it becomes greater than theta 1 at interface, angle of incidence at core cladding interface, it becomes less than critical angle. If it is less than critical angle, then light rays refracted into the cladding. After that, it emerges out from the cladding. Here, no reflection. Okay. So means to produce total internal reflection, the angle of incidence at end face of the core, it must be less than or equal to theta naught. That's why this theta naught we call as acceptance angle. Okay. What is acceptance angle here? It is the maximum angle of incidence to produce total internal reflection. Okay. So simply I will explain here. It is the fiber axis. Suppose if you fix this fiber axis and if you rotate the light ray like this, what happens? It forms one canonical shape. Okay, now we can say that the light rays which are incident within the cone, they only suffer total internal reflection. If the incident out of the cone, then there is no reflection. Light rays refracted into the. So that particular angle we call as, what is that angle? Acceptance angle. That is, we represent like theta naught here. Okay, so how we define acceptance angle? How we define acceptance angle? It is the maximum angle of incidence at the end face of an optical fiber for which the light ray can be propagated in the optical fiber. Okay, is it clear? Now we calculate acceptance angle. How we calculate acceptance angle? By using Snell's law at two different points. What are these two different points? One is at point O, another one is at point B. It is at point O, another one is at point B. So we know that what is Snell's law? W equal to sin I by sin R. Here at point O, light rays are propagating from air medium to core medium. Here refractive index of air is N0, cladding core refractive index is N1. Now if you apply Snell's law, so here it is the incident angle and it is the refraction angle. Now if we apply Snell's law, what is that? N naught sin theta naught equal to N1 sin theta 1. What is N naught here? Refraction and refractive index of air. Theta naught is angle of incidence. N1 is refractive index of core. Theta 1 is angle of refraction. Okay, from this sin theta naught equal to, we can write this like this. N1 by N naught sin theta 1. Okay, now seeing we apply Snell's law at point B. Okay, so again at point B, okay, at point B light rays are propagating from core medium to cladding layer. Here N1 is refractive index of core, N2 is refractive index of cladding. Here it is the angle of incidence 90 minus theta 1. Now if you apply here, then it becomes N1 sin 90 minus theta 1 equal to N2 sin 90. Then we know that sin 90 minus theta 1 is cos theta 1 and sin 90 is 1. Then N1 cos theta 1 equal to N2. Then cos theta 1 equal to N2 by N1. Okay, and we know sin theta 1. We can write like this, root of 1 minus cos square theta 1. Okay, substitute here, root of 1 minus N2 square by N1 square. Okay, so substitute this in equation 1. So sin theta naught